Welcome to my YouTube channel to all the students. Today in this video we are going to initiate one more form of the potential difference. One more form of the potential difference. The title is here. It is a 12th class physics. The title is line integral of line integral line integral of line integral of electrostatic field. Electrostatic field. Okay, electrostatic field. So in another way we can write, this is the topic where we are getting relation between the electric field and potential difference. Okay, electric field and potential difference. I am writing here relation between potential difference, that is V, potential difference, that is V, or electric field and potential difference here. Now for that, to get the relation, that in terms of the line integral, I am taking here uniform. This is a uniform electric field where field lines are equally spaced, and its direction is from left to right, okay. So here I am selecting 2 points. This is one point, say point A, and this is another point, point B. Okay. So here what happening here, see, when we take a small unit charge in this field, that is plus q naught, on this charge, due to that field, one force is exerted. That force on q naught, okay, due to electric field, okay, will be equal to what? Will be equal to, that force will be equal to q e vector, okay. And this is a repulsive force. We can say it is a repulsive force. Okay. If we want to move that charge from A to B, okay, if q naught is moving what, with a constant speed, okay, with the constant speed from point A, that is a initial point, from point A to B, okay, point A to B. So to move this one, what we have to do, we have to apply force, okay. If q is moving with a constant speed from point A to B, should apply force minus q naught e vector on q naught, okay. We have to apply this much force, okay, to move distance dl, okay. It is a small length, small distance, we can say here, okay. The work done is, in this case, the work done will be, that is dw equal to what? dw equal to minus q naught e vector into dl vector. This is the work done to move small distance of dl path in the uniform electric field, uniform electrostatic field. This is a small small work done. The total work done, then what? The total work done, working, not work done, but what? Total work done in moving from A to B. Okay, A to B, that is equal to W equal to integration of from A to B, that is A to B, that is equal to what? That is equal to dW equal to what? Here you write its value, that is A lower limit and B is upper limit, and value is minus q naught E vector into dl vector. Both are vector quantities. Okay, so therefore W equal to what? W equal to, here we can write it here, that is if we write it here, what? That is equal to what? Work done dw. Simply we can write, afterwards we can write this, we can substitute that limit. First you write integral part. Okay, that is lower limit A, upper limit B, equal to, if you substitute this value here, that becomes wb minus wa, wb minus wa. Okay, equal to, here this which quantity, that is q naught is constant, it is take outside in bracket, that is E vector dot dl vector, and if you take that minus, you write it here as it is. Okay, if you take here, that is wb divided by q naught minus wa divided by q naught. Okay, equal to minus of integral E vector into dl vector, and this quantity represents potential at point A, point B, that is vb. Okay, ये vb होता है potential at b point, and this is va, equal to minus of integration of E vector into dl vector. Okay, dl vector. Okay, this is a relation. From this we can write it here. The potential difference mainly depends on the electric field and path length, not playing any role of this charge. Q naught is not playing any role here. Okay, it is a interpretation characteristics of the points in the field. Okay, points in the field. ठीक है, तो हमें यहाँ पे थोड़ा पॉइंट्स लिखना है. क्या पॉइंट लिखना है? तो ये जो है ना लाइन इंटीग्रल क्या रिप्रेजेंट करता है? ये रिप्रेजेंट करता है समेशन. ऐसा सिग्मा, कौन सा? सिग्मा ई डॉट dl. तो ये क्या है? सिग्मा समेशन रिप्रेजेंट करता है. और नेक्स्ट पॉइंट क्या लिखना है? यहाँ पे इलेक्ट्रिक पोटेंशियल में यहाँ पे चार्ज का कोई रोल नहीं है. किसका रोल है? यहाँ पे पॉइंट्स का रोल है. जो पॉइंट्स हम सेलेक्ट करते हैं ना, उनका रोल मेन इंपॉर्टेंट है. तो ये लाइन इंटीग्रल फॉर्म में रिप्रेजेंट करने का एक वे है, जो इलेक्ट्रोस्टैटिक यहाँ पे रिलेशन बिटवीन ले सकते हैं. यहाँ पे देखो, यहाँ पे रिलेशन भी ले सकते. तो यहाँ पे जनरली इसका V बोल के लिए, तो ये V इक्वल टू क्या होता है? इलेक्ट्रिक फील्ड इनटू लेंथ. ओके, यहाँ ऐसे भी लिख सकते, E इक्वल टू V बाई N. V बाई एन। तो ऐसे भी हम यहाँ पे लिख सकते, ठीक है। इतना पॉइंट हमको याद रहना है। तो इसके बाद नेक्स्ट टॉपिक में हम क्या स्टडी करना है, इलेक्ट्रोस्टैटिक फोर्स इज अ कंजर्वेटिव फोर्स बोल के हमको यहाँ पे एक्सप्लेन करना है, वो नेक्स्ट टॉपिक में करेंगे, ठीक है। ओके।